Hi everybody, we're going to talk about solving trig equations. We're going to split up section 2.3 into two parts. Okay, so this is just the first part. I do want to tell you that this section, both parts 1 and 2, rely very heavily on you remembering the basic triangles, the 30, 60, 90, and the 45, 45, 90. So if you were kind of forgetting about those or you don't think you have them memorized, you really need to go back and review this because otherwise you're not going to understand how I'm solving the equations. Okay, so the first thing we're going to do is just look at an example. Okay, so I want to try to think of any angles that have 1 over root 2. Okay, and for part A, all right, we're just talking about angles between 0 and 2 pi. Okay, so the way that I do this is first I try to determine which triangle I'm talking about, or if this is a quadrantal angle. Okay, so when you see 1 and root 2, you should know that you're talking about the 45, 45, 90 triangle. Okay, so that's what I mean about this being heavily reliant on your previous knowledge is you have to recognize that anything that has a triangle with sides 1 and root 2 has to be a 45, 45, 90 triangle. Okay, and then I'm going to look at the sign, not this type of sign, but positive or negative, to decide what quadrant I'm in. Okay, so here I have sign is a positive value. Okay, so that means that I'm either in quadrant 1, okay, and I'm going to draw my little triangle in quadrant 1, okay, or I'm in quadrant 2. Okay, and again, I'm relying on your previous knowledge to know which quadrants have positive sign. Okay, so this would be 1 and root 2, right? 1 and root 2. Okay, now my reference angle I know is pi over 4. Okay. Okay, so in the first quadrant, if this angle is pi over 4, then that is my solution. So my solution for the first quadrant would be x equals pi over 4, right? And that means sine of pi over 4 is 1 over root 2. That's true, okay? Then in the second quadrant, this reference angle is pi over 4, which means this larger angle, right, is pi minus pi over 4, or 3 pi over 4. Okay, so there's my two solutions, one from each quadrant where sign is positive. Okay, now for part B of this question, okay, so let's take a quick break and say, what is this? Okay, so this is just a notation. Okay, so maybe you remember this, maybe you don't. This stands for real numbers. Okay, all possible real numbers. Okay, so when we say we're solving between 0 and 2 pi, we're restricting it to that first rotation around the circle. Now when we're talking about in R, that means any angle could be a solution here. Okay, now this is very similar. We're going to start with the solutions that we got from the first rotation, pi over 4, okay? And then we're going to say any coterminal angle. So remember, how do you get coterminal angles? Well, you add 2 pi, right? Or you add 4 pi, or 6 pi, or negative 2 pi, or negative 4 pi. Okay, so you're adding a multiple of 2 pi. Okay, so we're going to say Okay, the solution that we got from the first rotation plus some multiple of 2 pi, right? Any coterminal angles. So that's really the idea here is we're giving the solution that we got for part A, and then we're allowing for coterminal angles. Okay, and we're going to do that for our other solution as well. Okay, the solution that we got, and then you allow any coterminal angles. Okay. All right. So let's do another example. Okay. So here we're going to solve this equation. And again, we're going to start by solving it in the first rotation. Okay. So we're going to think about where we see root 3 and 2. And you guys know that this is in a 30, 60, 90 triangle. Okay. So we know we're thinking about a 30, 60, 90 triangle. And then we know that cosine is negative, meaning that the x coordinates are negative. So we're talking about quadrant 2. Let me just draw my little angle in quadrant 2. Okay, or quadrant 3. Okay, so that's again because we know that cosine is negative and cosine has to do with the x coordinates. Okay, so we have negative x coordinates here and here. Okay, so we can label them, right? This would be root 3 and 2 minus root 3. This would be minus root 3 and 2, right? This would be 1, by the way. Okay, now we know that here, right, because this is the smaller side, it has to be across from the smaller angle. This is pi over 6, and so is this. Okay, our reference angle is pi over 6. Okay, so our larger angle here is going to be pi minus pi over 6, or 5 pi over 6. Okay, and then here we have pi plus pi over 6, or 7 pi over 6. Okay, so same reference angle, pi over 6, 2 different quadrants. Okay, now for part B, okay, we're going to include all coterminal angles. So we're going to take my solutions from the first one, okay, and then add coterminal angles. Okay. All right. Let's do one more example that's like this. Okay. So we're thinking about what triangle has tangent equal to 1, okay? Again, for part A, we're going to be looking at just the first rotation, okay? So we're thinking about one tangent has, it's equal to 1, okay? So tangent is equal to 1 when the sides are the same length, okay? So that's going to be in the 45, 45, 90 triangle. Okay, and then we're going to think about where tangent is positive. So all the trig functions are positive in the first quadrant, so that's a possibility. Okay, and the other place that tangent is positive is in the third quadrant when both x and y are negative. Okay. So this would be when we have 1, 1, and root 2, or -1, -1, and root 2. Okay, so of course our reference angle is 45 degrees, right, or pi over 2. Okay, so in quadrant 1, that means that our actual angle is pi over 2. Oop, I'm sorry, pi over 4. Okay. And then in the third quadrant, we've got pi plus pi over 4, which is 5 pi over 4. Okay, so there's our first solutions in 0 to 2 pi. Okay, then for part B, when we want all of our solutions, okay, we're going to take our initial solutions and add all the coterminal angles. Okay, all right. So that's the basic idea of how to solve these equations. You have to determine which triangle you're talking about and then figure out which quadrant you're in. Okay, so let's look at a more complicated example. Okay, so for this one, we're only looking for solutions in 0 to 2 pi. And let's look at our equations. Okay, so before we jump right to saying, okay, well, sine is equal to this, we know what quadrant we're in, all of that, we need to actually get sine of x is equal to a number. So when I look at this, I can see that this is the difference of squares. So I'm going to factor this. Okay, and then like you do with solving by factoring, I'm going to set each factor equal to 0. Okay, and then I'm going to isolate the sine x. Okay, so that's the part that's new information. Okay, we were talking about before, just we had sine of x equals something. Now we're doing a technique to actually get to that point. But you guys have seen factoring with the trig functions, and now we're just setting each factor equal to 0. Okay, so now it's time to think about when sine x is equal to -1. Well, that's not true in either of the special triangles, right? So when that's the case, we want to think about the quadrantal angles. Okay, remember sine is about y values, so we want a y value equal to -1. Okay, so if I draw that, I want my y coordinate to be -1. Okay, so what angle is this? This is 3 pi over 2. Okay, now if I want the y coordinate to be equal to +1, that's up here. Okay, and that's the angle pi over 2. Okay, so because these are quadrantal angles, we're only going to get one solution for each one of these two factors. One solution for -1, one solution for +1. Okay, let's see another example that uses that technique, the factoring. Okay, so this has a common factor here and here, so I'm going to factor out cosine x. Okay, and now I'm going to set each of my factors equal to 0. Okay, now here I already have cosine isolated, so over here I'm going to add 1 to both sides. Okay. All right, so I'm thinking about where cosine is 0. Again, neither of the special triangles, so it must be a quadrantal angle. Okay. So this is telling me I want my x coordinate, right? Because remember, cosine has to do with x. I want my x coordinate to be 0. Okay. Well, there's 2 quadrantal angles where the x coordinate is 0. This one, okay, which would be pi over 2. Okay. Or here. And this would give me x equals 3 pi over 2. Okay. All right. So we're going to do something similar here. Cosine x equals 1. We know that that has to do with the x coordinate is 1. So we're going to look for where the x coordinate is 1. That's here. Okay. And there's something that I wanted to point out about this. Okay. Now, normally you could list this angle as either 0 or 2 pi, but let's look at the original question. Okay. So the solution interval includes 0 and does not include 2 pi. Okay, so for that reason, we're going to list this angle as 0. Okay, just because of how the interval is written at the very beginning. Okay, so there would be my 3 solutions: pi over 2, 3 pi over 2, and 0. Okay. All right, let's look at a couple more examples with factoring. Okay. So you can see this has 4 terms. The terms have no common factors, so we're going to factor by grouping. So for my first group, they have 2 cosine squared x. Okay. And then that would leave me here with cosine x and here with minus 1. Okay. Now here, to match this factor, I need to factor out a negative 1. So I'm going to do that. Okay. All right. So now I'm going to factor out my common binomial, which is cosine x minus 1. Okay. Now what's left over from my first group is this 2 cosine squared x. Okay, and what's left over from my second group is minus 1. Okay. Now this, not the difference of squares, you could factor it as the difference of squares using root 2, or you could just leave it like this. Okay, so I'm going to leave it and I'm going to factor, I'm going to set both of my factors equal to 0. Okay, so here to solve, all I need to do is add 1 to both sides. Here I am going to add 1 to both sides. And then divide by 2. Okay, and now I still have cosine squared. Okay, so I'm going to square root both sides. And that gives me a plus or minus. Okay, so we'll come back to that in a second. Let's look at where cosine x equals 1. Okay, we actually already talked about this. When cosine is 1, you want the x coordinate to be 1, so that would be here, okay? And again, because it includes 0, we're going to use x equals 0. Okay, so that's one of our solutions. Now let's draw our attention to the cosine x equals plus or minus root 1 over root 2, okay? So 1 over root 2, we know is a 45, 45, 90 triangle. Okay, now because it says plus or minus, that means it could actually be in any of the 4 quadrants. Okay, but our reference angle is always pi over 4. Okay, so in the first quadrant, this would give us x equals pi over 4. Okay, in the second quadrant, it would be pi minus pi over 4 or 3 pi over 4. Here it's going to be pi plus pi over 4 or 5 pi over 4. Okay, and here it's going to be 2 pi minus pi over 4 or 7 pi over 4. Okay, so we're only getting one solution from this factor, but we're getting 4 solutions from the other factor, and it's because we have this plus or minus. Okay, the plus or minus was what before was letting us tell which quadrant we were in, but because we have both choices, we could be in any of the 4 quadrants. Okay. All right. I think that's enough examples. I encourage you guys to try some of these problems before you watch part 2. Part 2 is a little bit different than this, so please practice this, review your special triangles, and I will see you guys soon.